Hey folks, thanks for coming back. All right, continuing with inequalities, we're going to talk about how to solve them now. Just basic one-step inequalities. We're going to talk about, I'm going to look at two presentations. We're going to look at solving with addition or subtraction, and then we're going to look at solving with multiplication or division. So this is going to be really reminiscent of solving one-step equations. All right. So the rules for solving inequalities are the same here. Now for adding and subtracting, it's just really straightforward. Solve it just like you would an equation. All right, so if it's an inequality where you see addition, you're going to solve with subtraction and vice versa. So here we have a couple examples. X plus 7 is greater than 10. So we're going to subtract 7 from both sides of our inequality symbol, and we will get that X is greater than 3. All right, and if I was going to graph this, I would graph my answer. I would graph X is greater than 3. I would not graph my original. That there's really no way to properly do that as far as I know. All right, down here, X minus 4 is less than 12. We would just add 4 to both sides. We would get that X is less than 16. Once again, this is what I would be graphing. Okay, I've graphed my solution. Let's do another set. All right, just some more practice here. X minus 3 is greater than 22. We just add 3 to both sides of our inequality symbol, and we would get that X is greater than 25. All right, over here, X plus 10 is less than 108, so I would subtract 10 from both sides, and I would get that X is less than 98. All right, coming down here, we have negative 5 plus X is less than or equal to 15. Since this is a negative 5, you could say, oh, I'm going to subtract negative 5. That's true, you would. But that's also the same as just plain adding 5. All right, so we're going to add 5. Since that's a negative 5, we add a positive 5. And we would get that X is less than or equal to 20. All right, and finally, we've got 50 is greater than or equal to X plus 12. So we would be subtracting 12 from both sides, and we would get that 38 is greater than or equal to X. Okay? All right, well, let's go ahead and look at multiplying and dividing here. All right, so looking at multiplying or dividing, we're going to solve it just like an equation. There's a little bit of a catch we're going to look at here in just a minute, but we're going to solve this just like we would an equation. Okay, so if you see multiplication, you're going to divide, and if you see division, you're going to multiply. So here we have 3x is greater than 27. So we're going to divide both sides by 3. When we divide both sides by 3, we see that x is greater than 9. Here, we have x divided by 2 is less than or equal to 6. So we're going to multiply both sides by 2. And when we do that, we get that x is less than or equal to 12. All right, straightforward. You guys remember this, right? So there is a special case when it comes to multiplication or division. And that is that if you multiply or divide by a negative number, the inequality sign will flip. All right? So here we have negative 4x is greater than 6. So we have to divide by negative 4. All right, and when we do that, we get that x is less than negative 1.5. Or negative 1.5. All right? So notice that my inequality sign had to flip. It went from a greater than sign to a less than sign. Here we have x divided by negative 3 is greater than or equal to 5. So in order to solve this, I have to multiply by negative 3. And we would get that x is less than or equal to negative 15. All right? Notice, again, my inequality sign had to flip. Now, you might be wondering, why do we have to do this? So I'll show you. All right, we're going to pick a value for x that is true. So if x has got to be less than negative 1.5, let's go with negative 2. Let's say that x is negative 2, and let's plug it into both of our inequalities. So if we plug in negative 2 for x here, we'd have negative 4 times negative 2, all right, is greater than 6. So if we solve it, negative 2 times negative 4 is a positive 8. All right, which is greater than 6, and that's true. Okay. Down here, if we plug in negative 2 for x, we would get negative 2 is less than negative 1.5. And that's also true. All right, so you see, if we would have left our sign as a greater than sign, this statement would no longer be true, all right, because negative 2 is less than negative 1.5. So that's why we have to flip our sign. We'll do it over here too. So we're going to pick something that is less than or equal to negative 15. So we'll go with negative 20, okay? So we do, now let's not do negative 20. Let's do negative 18. If we do negative 18, we'll have negative 18 divided by negative 3 is greater than or equal to 5. All right? Negative 18 divided by negative 3 is a positive 6. And that is greater than or equal to 5. Okay, so that's true. All right? Then if we just go with our inequality here and we plug in negative 18 is less than or equal to negative 15, that is also true. All right? If we would have left our sign where it is, it would no longer be true. So you see that both statements have to be true. That's why we have to flip our sign. All right. Just to practice a couple real quick. All right, so 3x is greater than 24. If we divide by 3, we get that x is greater than 8. Okay, coming over here, x divided by 10 is less than or equal to 8. So we multiply both sides by 10. We get that x is less than or equal to 80. All right, coming down here, we have negative 5x is less than or equal to 15. So if we have to divide both sides by negative 5. And we would get that x is greater than or equal to negative 3. Don't forget to flip your sign. All right, and over here we have 6 is greater than x divided by negative 12. So we have to multiply both sides by negative 12. And we get that negative 72 is greater. Nope, I already messed it up. Is, we have to flip our sign, less than x. All right, that was a lot, but thanks for hanging in there, and we'll check you later.